How's it going, Global Hack Week? Oh, let me make my screen bigger. There you go. My name is Rosendo from MLH. I just wanted to let y'all know that we are super thankful to have you. This is going to be the tail end of day 3 of Global Hack Week. So, depending on where you're joining us in the world, it could be the morning, afternoon, or evening for you. We are really glad that you are here. We've got some great content gearing up for you today. We've got our friends from LavinMQ joining us to teach us how to scale our applications with LavinMQ. So if you haven't heard of LavinMQ before, you're going to learn all about it today. This is a great workshop for any level of hacker. So depending on where you're at in terms of your hacker journey, I think this is going to be a great place for you to start with things like message brokering. If you've never heard of it before, you will learn today. So yeah, I mean, let us know if you have any questions in the chat. Make sure to stay engaged and yeah, we'll get to every single question. Just like I said, drop them in the chat and we will get to them at some point in the workshop. With that being said, give a warm welcome to Christina and Yor. Hi, folks.
Hello.
I'll leave
Thank
y'all
you
to
so much for having us. Yeah, great. Okay, thank you. Okay. Hello, MLH community. So excited to be here to do this workshop today. I think we can get right into it, right, Nior? Start out with the presentation and get some content going. Okay, yeah, so let's get started with today. We're super excited to be a part of this open source hackathon. We work a lot with open source, so this is going to be really fun to partake in. And yeah, we're really glad that you're here to listen to us talk a bit about message queuing. It's something that we work with every day, so it's really fun to come out to things like this and talk about it. And yeah, we have a lot of fun stuff to go through. So I'm going to try to keep it simple and really relaxed so that everybody can benefit. And I guess we'll get right into it. Yeah, so we'll go through some background on message queuing. And we're going to walk you through what message queuing is and what it can be used for. And then we'll introduce our own message broker, LavinMQ, and talk a little bit about what makes that special. And then we're going to go through some theory on the AMQP protocol, which the message broker is based on. And yeah, after that, we'll introduce the hackathon challenges that we've provided for this hackathon. And lastly, we're going to follow up with like a little bit of a live coding session that's supposed to help you kind of get on track with installing the software and solving the LavinMQ related parts of those challenges. Yeah, but first I want to just begin with introducing myself. My name is Christina. I'm based in Stockholm, Sweden. And I'm a software engineer at a company called 84 Codes, where I also work as a project lead for the LavinMQ project. And I've been at 84 Codes for about 3 years now. And before that, I studied a master's degree in computer science. So that's kind of my background. And yeah, in my free time, I love to travel and I love to see new places. And as you can tell by the picture the picture at the top, I really, really like to ski. Go out on the mountain. So yeah, now you know a little bit about me, and I'll pass the mic over to my colleague, Neil. Let's see if we can switch the screens.
Yep. Great. Thanks a lot. Hi, everyone, once again. Thank you so much for tuning into our workshop. If you were here for the data week, you probably had seen us. It was so much fun. So it feels really good to be back in the community today and talk to you about message queuing with LavinMQ. A few things about myself. I am Neil Clement, and I work as a developer advocate on the 84 Codes team. I've been in this role for almost 2 years now, working with message queues, writing about them, and speaking about them as well. Outside of work, I like to build things for the web with Python. And today I am speaking to you from Abuja in Nigeria. It's super warm here, so I'm mostly indoors during the day, but the nightlife is amazing. And every now and then I like to go out and just try out something new. Like the picture in the second frame where I'm looking so scared and nervous because I was trying out go-karting for the first time. And Yeah, that's it for the introduction. Now let's talk about message queuing with LavinMQ. Now, I'd like to start with a quick survey or question. If you've worked with RabbitMQ or message queue like RabbitMQ or our own broker LavinMQ in the past, just say yes in the chat box. And if you haven't, just say no. Don't be shy to say no because we're just trying to get a sense of who we have in the audience today. I'll just give us 5 to 10 seconds to do that. And now the awkward silence begins. 5 to 10 seconds.
Looks
We
like we're
are
getting a lot of no's in the chat,
no.
but that's good because then we can.
Yeah. Are you able to see it on your end, Christina? Because I can't even see it.
Yeah, we're getting a couple of no's in the chat, but
Oh,
that's great because
okay.
that means that we can teach
Yeah,
them.
yeah, that's totally fine because our presentation today is super beginner friendly, and we're going to start from the very beginning. What are message queues? Now, personally, I like stories and analogies a lot because I think they're very fascinating. I don't have a story for you today, but to help you explain message queues in a very approachable way, I am going to use an analogy, a concept that you're super familiar with, most likely databases. Now, databases are primarily used for data persistence. You store some data. You think of technologies like Postgres or MongoDB, right? Now, like databases, message queues also perform some storage function. They also store some data. But this raises the question, if we already have databases for data storage, why then do we need message queues for the same thing? To answer this question, let's think of databases and message queues in terms of warehouses and post offices. Now, databases are like warehouses. They're designed to hold a lot of different things, most times over a long period of time. Message queues, on the other hand, are like post offices, where letters and packages stop briefly on their way to being delivered. These packages don't stay there for long, they just sorted and sent off to where they need to go to. Essentially, now if we put everything together, right? Essentially, databases are primarily designed for scenarios where you need to persist and manage some state over a long period of time. In contrast, you would want to use a message queue for data that you do not want to keep around for very long. It's basically a message queue holds an information just long enough to send it to the next stop. Now, if you look at message queues and message brokers from this post office perspective, then you'll begin to appreciate the fact that a message queue is simply a medium through which data flows from a source system to the message queue, and then from the message broker to the destination system. Now, I would want to admit at this point that looking at message queues from this perspective of being a medium of communication between this source system and a destination system is just one way of looking at it, really. But we're trying to just keep everything simple here. And besides, this is sufficient to just help you get started with this concept of message queues. So let's double down on that perspective. There are some formal terms we need to be aware of in the message queuing world. The source system, where the data originates from, is called the producer, and the data sent to the message queue is called a message, and the receiving application is called the consumer. Now, one important thing you need to note about message queues here is that the data sent to a message queue is usually lined up in the exact order they arrive, and that's why it's even called a queue. And now that we understand the core essence of what message queues are, let's explore some of their practical use cases. We've already seen how message queues allow messages to flow from producers down to consumers, right? This inherent behavior of message queues make them perfect for communication between the systems in the microservice architecture. But what is the microservice architecture, you ask? Or maybe you didn't ask. I'm still going to tell you anyway. To explain microservices, again, I'm going to just start with something you're familiar with: a monolithic application. Now, a monolith is characterized by the entire code base being inside one application. Now, this is a great approach for smaller projects, and many new applications, in fact, actually start out as a monolith. This is because on a smaller scale, a monolith is faster to develop, easier to test, easier to deploy, and generally easier to manage over time as well. However, when an application starts to grow, the more problems you will see with this architecture. I will give you 3 examples of these problems. First of all, a large monolithic application makes development more complex and slower, and it's a bit harder to onboard new people to a monolithic application, and that's because the developer is being presented with this huge code base that they have to go through and try to understand at once. The second problem is a small change to a monolithic application would usually require you to rebuild your entire application and then redeploy it again. The third problem is if there's an error in one module of a monolith, it could affect the entire application. Now, I could go on and on telling you about the problems of a monolith, right? But hopefully you get the point at this point, no pun intended. Yeah, these are some of the problems. Now, the question is, we've seen the problems. Sorry, I have to just make sure I'm on the right slide. Give me a second. Yes, okay. We've seen the problems, right? What is the way forward? What are the solutions? Now, many times the solution to these problems we've seen with a monolith is to break up your huge monolithic application into smaller applications called microservices, with each service focusing on a single area of responsibility. And this approach has some benefits. First of all, with microservices, it's easier to implement changes to your code, and it's also easier to onboard new people as well. Because when you onboard a developer to a distributed architecture, most times they will be focusing on just a few of these services, not the entire services in your stack. There's fault isolation as well with microservices. So what this means is if one service is faulty, the bug will be isolated to just that service, really. This makes your application more reliable compared to a monolith, where a single component error could take the entire application down. There's also the opportunity to be able to diversify the technology stack from service to service. So for example, you could have a service written in Ruby that talks to a service written in Crystal or Python. Consequently, this could help you optimize your services for its purpose. For example, a performance critical service has the chance to make certain performance trade-offs without putting limits on the rest of the services. And lastly, with microservices, scaling becomes so much more easier because you can just scale one of your services instead of scaling the entire application. This in turn could save you a lot of resources. Now that we understand what microservices are, let's cycle back to the point we're trying to make: how message queues can allow the services in a microservice architecture to communicate with each other. But before we get to that, I'd like to mention at this point that message queuing isn't the only way of getting services to communicate, really. There's one other common approach: synchronous communication. And in this approach, the services will talk to each other directly via, let's say, REST API calls. And for example, if you have, let's say, 2 services, service A and service B, and you're going with this synchronous approach, the communication would work out this way. Service A will initiate a request to service B and then wait for service B to finish handling the request. During this waiting time, service A does nothing. Eventually, it gets a response from service B before it continues on with the activity it was doing. Now, one of the biggest flaws of this synchronous approach is that the services here are tightly coupled and super dependent on each other. Now, with message queuing, things are a bit different here. The communication is asynchronous. Now, instead of having the services communicate directly, you put a message queue between them. As a result, service A will send messages to the broker, and instead of waiting for service B, it will receive a super quick acknowledgement back from the broker. Service A can then carry on doing what it was doing while service B fetches the messages from the queue and handles it. Now, this asynchronous approach to communication between services with message queues is more decoupled approach, where the services don't have to be online at the same time to be able to talk to each other. To illustrate this notion of using message queues in distributed architectures practically, let's look at an example of building, let's say, an e-commerce application. Now, if you're building your application the microservice way, you would typically build a couple of different services. For example, you could have a service for handling inventories, a service for registering orders, and a service for making payments. Now, when a customer goes to buy an item on your platform at checkout, they fill in their information and click pay. Once they do that, the checkout service will send the request to the payment service, and the payment service will start to handle the request. However, it needs to connect, that's the payment service, needs to connect to the bank, and we cannot predict for sure how long the bank will take to process the payment since it's an external API. This means the checkout service and ultimately the users are left waiting until the payment process is finished. But sooner or later, the payment service and by extension, the bank will finish and send back confirmation on the payments. During the payment processing, the customer will be waiting for the screen to show confirmation of the payment. This is mostly because the services are working synchronously. And this is a pretty bad user experience, especially if it takes the payment service long to process the payment. The user experience even gets worse if you start getting a lot of those requests, because then you'd have the payment service trying to process multiple payments at the same time. With a message queue, on the other hand, you're able to reduce the waiting time significantly. And this is true because with message queuing or asynchronous communication in the picture, the checkout service will send a message to the broker and return a response instantly to the user. This response would be a promise that their order has been placed and that the receipt will be sent to them soon. So yeah, that was an example of how message queuing can be used for communication between services. And now that we understand what message queues are and when to use them, let's try to get a sense of how messages flow from a producer to the message queue and then to the consumer. Now, producers and consumers would usually connect and communicate with the message broker via some messaging protocol. And for the producer or consumer to have that communication happen, they would leverage some client library that implements the protocol or the broker they're connecting to support. Most message brokers commonly implement at least one of these protocols: AMQP, MQTT, and Storm. Now, LavinMQ, or the message broker will be focusing on in this workshop, implements the AMQP protocol. I will now hand it over to Christina, who will tell you more about LavinMQ and how it implements the MQP protocol. Over to you.
Right. Thank you, Nior. That's a great explanation that you just gave. Okay, so I'm going to jump in here and ask the question, what is LavinMQ? Yeah, now that you've gotten an overview of what message queuing is and what it can be used for, I'm going to go into detail a little bit about the actual software and explain what LavinMQ actually is and how it works. And yeah, LavinMQ is our own message broker that we have developed in-house at 84 Codes. It's an open source project, so you can find it on GitHub, and you can visit the GitHub repository and follow along in the development if you're interested in that, or if you're in need of information about how to get started with installing and stuff like that, you can find a lot of great information there. I will show you a little bit about that later, but if you need to come back to that information, it's all on GitHub. So that's good to know. LavinMQ, it's a message broker, like I said, but I guess the question is, what makes it special? Why have we developed our own? And what makes it special is that it aims to have a very low memory footprint, and it kind of uses the memory resources of a machine or the machine that it's working on in a much more efficient way than other brokers right now on the market. So on a usage level, LavinMQ is very similar to other AMQP brokers. Some popular ones could be RabbitMQ or ActiveMQ, but different from these is that they're fundamentally different in the architecture and how they have been developed. So one example of this is that instead of caching messages in the process memory like other traditional message brokers often do, in LavinMQ, we let the operating system handle that caching, and then we write all of the messages down to disk. And this is actually much faster because we do it in a way that lets us avoid making a lot of expensive read and write syscalls down to the kernel of the computer, and that gives us a significant performance boost. And that's kind of one of the main selling points of LavinMQ, is that you can push over 1 million messages per second, and you can get some really impressive throughput performance if you compare it to other alternatives. So yeah, other than being really efficient and fast, it's also super lightweight, and the code base is pretty small. So, and it also needs minimal configuration to get up and running. And yeah, it's pretty easy to use as a beginner, which is something that we're really proud of when we develop LavinMQ. So yeah, to explain how it works on a usage level, I want to go through the protocol that it uses, AMQP, and I'm going to touch on the basics of how an AMQP message broker works. So AMQP, we've said it a lot of times now, and what it stands for is Advanced Message Queuing Protocol. And it's the protocol that message brokers like LavinMQ use. It's also found in other popular message brokers like RabbitMQ or ActiveMQ. And with an AMQP message broker, like Nior has kind of mentioned already, you typically have a publishing service that publishes messages to the message broker. And in order to publish messages, the publisher is going to open a connection towards the message broker. And in AMQP, a connection is like a virtual link between your application and the message broker, which is going to open a line of communication between the two services. And an application typically wants to interact pretty frequently with the message broker, and connections can be pretty expensive to open and close. So instead of opening and closing that connection all the time when you're sending messages, you can reuse a connection and you open something that's called a channel. So channels allow for connection multiplexing, which means that you can have many smaller connections on one larger physical connection. And you can think of channels as kind of lightweight pathways within the connection. And each channel is capable of carrying its own stream of messages. So by using channels, you can then reuse a connection and avoid opening and closing connections between the application and the message broker. And in that way, you save a lot of performance. So yeah, once you have a connection established between your service and the message broker, you want to send messages from your producer to a queue in LavinMQ. And you can then open a channel and send a message on that channel. So when you send a message into LavinMQ, you don't publish messages directly to a queue. Instead, you're going to publish them to something that we call an exchange. And an exchange is a routing mechanism that's going to route your message to the correct or to the intended queue. And just to kind of show you quickly how that works, I have an example here. The exchange uses bindings, or something that we call bindings, and routing keys to determine what queue it's supposed to send a message to. So a message is going to come in and it's going to have a routing key attribute that I have in this example named Q1. So now the exchange is going to look at the bindings that it has. You can see here that it's bound to 2 queues. So it's going to look through those bindings and it's going to match the routing key with the bindings routing key. And then that message is going to be able to find the queue through that exchange. And yeah, this is the most simple type of exchange. It's called like a direct exchange. There are other types of exchanges that allow for more advanced routing techniques, but I'm not going to go too deep into that here, just to kind of keep it simple. Because we have great documentation on how this works on our website. So if you want to try out different types of exchanges in your solutions, I recommend that you follow some of our tutorials or read the documentation on LavinMQ.com. Yeah. Okay, so continuing with the example that I was showing you here with the routing. So the publishing app is going to send a message with a routing key of Q1, and that message is then routed through the exchange into the queue Q1. And that message is going to be able to stay in that queue until a consumer comes and subscribes to that queue and consumes the message. And the message will be then removed from the queue once it has been consumed by the consumer. And yeah, that's basically the message flow of an AMQP message broker. It's not really much more advanced. It doesn't have to be more advanced than that. And now I think I'll take a break from talking and I'm going to let Muir introduce the hackathon challenges that we have provided. And then I'm going to come back in the end and I'll show you a live example on how to code what I just showed you. Yeah, over to you, Muir. I think you are still unmuted. Okay, yeah, good. Muir, I think you are muted. I can't hear you.
Yes, I was muted. All right, so I'm going to start all over again. So the challenges, we have 3 categories of challenges for you: the registration challenge, the coding challenges, and then win some LavinMQ swag challenge. Actually, this is just a bonus challenge that you don't have to work on. But if you work on, then you stand the chance to just receive some goodies from us at LavinMQ. I'm going to start with the registration challenge. Very straightforward. Here, we just encourage you to join the LavinMQ Slack and ask any questions related to this hackathon in the Global Hack Week channel. So we have a dedicated channel for you to just answer your questions there. And don't forget to give us a star on GitHub, and our friends at Crystal as well. Don't forget to give them a star on GitHub. Now, the coding challenges. We have 7 sets of challenges for you here. I know they might look scary that we have 7 challenges, but it's just one thing you'll be building. So instead of asking you to build this entire thing in one single step, we wanted to just make it easier for you. So we've broken it down, the process of building it, into the 7 steps that you could follow more easily. Now, the objective of this challenge, what would you be building? You're going to build a rudimentary, a simple web crawler that will go to a page, grab all the links on that page, send the links to LavinMQ, and then you have a consuming application that would read these URLs from LavinMQ. I'll just go over it again just so you get it. So you're going to build a very basic web crawler that will go to a web page, grab all the URLs on that web page, send the URLs to LavinMQ, and then you have a consuming application that would read these URLs from LavinMQ. I think one of our core objectives is to teach you Crystal and LavinMQ at the same time. And that's why one of the requirements for this challenge is for you to complete it in the Crystal programming language. So, yeah, just so you learn it in the process. I'll quickly go over each challenge just so you get a sense of what is expected in each phase. Challenge one is just hello world, really. You're just expected to write a hello world program in Crystal. And to make things easier for you, we have hints for each challenge just to help you, and links to related documentations as well that you could just that you could read through and just figure out how to go about the challenges. So challenge one, you write a hello world program. Challenge two, you're supposed to extend your hello world program into a web crawler. At this point, it is a very dumb web crawler. You just have a fixed URL that it goes to and grabs it grabs all the content of the URL at this point and logs it to the console. Again, we have some hints for you. Challenge three, now you expect to make things a bit more dynamic. So instead of working with a fixed URL, your program should accept a URL from the command line and then go to the web page, grab all the content and just log it to the console. Challenge four, this is where things start to get a bit interesting. So instead of just grabbing all the content and logging it to the console, you're supposed to pass the content of the web page you're crawling and grab all the links on that page. And you're not doing anything special with the links at this point. You just log each link you grab to the console. Now, challenge five, this is where you start to work with LavinMQ. In challenge four, you grabbed all the links on the web page. Now, in challenge five, you publish all these links to a queue you would create in LavinMQ. Christina will soon show you how to work with LavinMQ, how to declare queues and exchanges. So, yeah, pay attention. Then challenge six, remember when we talked about MQP, we both mentioned how you have a producer that sends messages to the queue, to the message broker, and then you have a consumer, right? So in challenge six, this is where you write your consumer application. And what it does at this phase, it reads all the URL in the queue and it logs it to the console. Now, it doesn't do any processing on these links at this phase in challenge six. Now, challenge 7A, challenge 7B, they're basically the same challenges. This is where you start to do some processing on the URLs. That's it for the coding challenges, really. And like I said, doing some LavinMQ swag, this is just a bonus challenge if after all these challenges you have time. But this is something you could also do way after the hackathon. If you've learned something interesting about LavinMQ, or you just want to share some stuff you've discovered, you could just write a blog, share it on LinkedIn, Twitter, or on our LavinMQ Slack and tag us. Yeah, and that's it for the challenges, really. Now I will hand it over to Christian, who will walk you through Crystal and how to work with LavinMQ. Over to you.
Okay, cool. Nice. Okay, so now we're through like the presentation part of this workshop, and now we're gonna get our hands dirty with some live coding. Let's just hope everything goes as it should. I'm gonna roll up my sleeves and we can jump over to the terminal. Yeah, okay. So we're gonna, this part of the workshop is mainly here for you to kind of get started with your projects and be able to like get something up and running, right? So what we're going to do is we're going to build a publisher and we're going to build a consumer, so two apps that are going to publish and consume from a LavinMQ queue. So it's a very basic example, but it's going to help you kind of get started with these web crawler challenges. And to kind of get started, we're gonna have to install Crystal because LavinMQ works with Crystal. So you can go to like crystallang.org/install, and then there's going to be instructions on how to let's just see. Don't know why it's going to full screen mode, whatever. Okay, so we have, yeah, if you have Linux, then you can just follow these instructions. Mac OS, Windows is a preview, but it should work if you follow the instructions. So that's step number one, is to install Crystal. And step number two is going to be installing LavinMQ. So the message brokering software that you're going to be using when you're coding these apps. And to do that, one simple way that should work for everybody is to just clone the repository on GitHub and kind of just like, do git clone, copy the address and just clone the repository into some folder that you have locally on your computer. And then we have instructions here on how to kind of get it up and running. So you clone the repository and then you run the make command, which is going to build the project for you. And then you can run LavinMQ with the command LavinMQ-d, and then you just feed it with a repository that you want to run LavinMQ on. And this is what I'm going to be doing because it kind of gives me the LavinMQ logs in an intuitive way for you guys to see here in the terminal. And you're going to see like everything that's happening with the message broker when it's happening. But another thing that you could do is that you could use like a package manager, something like Homebrew or apt-get. You could use to just install LavinMQ, and you're going to be able to run LavinMQ like that. Another thing is that you could use Cloud AMQP and create an instance, a free instance on Cloud AMQP and use LavinMQ from there. That means you're going to get like the interface via Cloud AMQP. But that also works. And then you're not doing it like locally, then you're going to have like a virtual host that you're going to connect to. But yeah, that's also an alternative. Okay, so I guess let's get into coding then. Okay, so we're going to begin with coding the consumer. So I'm just going to create a new file here that's called consumer.crystal. I'm going to be coding in Crystal because that's the language that I work in and that LavinMQ is coded in. And yeah, we're partnering up this hackathon with the Crystal team. Actually, they had a workshop, I think this Friday, where they had some introduction to the Crystal language. And yeah, I'm in big favor of you guys learning a new language. So check out Crystal. Okay, so to start building our consumer, we're going to want to use something that's called AMQP client in order to be able to communicate with LavinMQ through the AMQP protocol. So I'm going to require a library here. Require something that's called AMQP client, like that. So now I can use that.
Christina,
yes.
Do you think you can zoom your IDE a bit?
Of course. Thank you for reminding me of that. I would have gone the whole workshop without it if you didn't say it. So that's great. Perfect. Is that good?
Yeah, it's visible now.
That's great.
Yeah. Oh.
Okay, perfect. Okay, so now that I've required AMQP client, I have to client. I think that's good. Yeah, then I can start using that library and use a namespace that's called client and do start. And that's going to start a connection on or to LavinMQ. And so it's basically going to start like a client connection towards LavinMQ. And I'm going to just show you guys that this doesn't compile, and then I'm going to explain why it doesn't. I'm going to just show you guys that this doesn't. Let's see. So yeah, you can see here that it doesn't compile because it doesn't recognize the AMQP client library. And that's because Crystal has something that's called shards, which is like the dependency manager for Crystal. So we need to initialize a shards file, and then we need to install the dependencies. So I'm going to do that now, just to show you how that's done. I just run shards init, and that's created a file that's called shard.yml. So it's a YML file here where we can define our dependencies. And for this project, I'm only going to have to use 2 dependencies. The first one being AMQP client, which we are using directly in our app. And the second one is going to be AMQP protocol, which is something that the AMQP client uses. So I'm going to save that. Then I'm going to go back to the terminal and I'm going to do shards install. And that's just going to fetch those repositories and install them for our project. And you can see that we get a little lib folder here that holds our dependencies. And now when I try to compile this, it should work, hopefully. Oh yeah, and it doesn't work, which is expected because LavinMQ is not running. So let's just turn LavinMQ on first, and then it should be able to compile. Famous last words is always, now it should work. Never works. Okay, so LavinMQ is running. We can see the logs down here. So now when I run my app, we're supposed to be able to connect towards LavinMQ. And now it works. You see here that the application is able to establish a connection and then it disconnects. And up here in our program, we can see that we output hello world to the terminal. So everything is going smoothly. Now, like I told you guys earlier, when we open a connection and we want to start publishing messages or consuming messages for that matter, we're going to want to open a channel on that connection instead of opening and closing the connection all the time. So that's what I'm going to do here. I'm going to take the client that we're feeding this block here, and I'm going to say client.channel do, and then I'm going to create a channel here. And now that we have a channel, I'm able to like declare queues, subscribe to queues, publish messages to queues, all on this channel. So yeah, I guess that's what we're going to start doing now. So I want to declare a queue that we're going to be working on. And that queue is going to be declared on this channel. So I'm going to say channel.queue. And I'm going to name that queue. Let's call it my queue. And then I am going to, let's see, I'm going to, after this, I'm going to output some sort of message just so that we get some feedback in the terminal. I'm going to say, I'm listening for messages. Press Control plus C to exit. Okay, so the thing with a consumer is that it's going to be listening for messages that comes in on the queue. So when there comes a message on this queue that we've declared up here, we're going to be able to consume it. So we're going to be listening on that queue. And to do that, we have to subscribe to the queue. So we're going to say queue.subscribe. And I'm going to do this in order to, this just kind of keeps the subscribe loop alive so that we're keep on listening to the queue. Otherwise, it just listens to one message and then exits. So this is going to keep it alive. And this is going to yield the message that comes in. So I'm going to then, when we get a message, I want to output that into the terminal. So I'm going to follow GitHub Copilot here and just say that we print out received message. Okay, so let's save this and try and compile and run that. Okay, good. So now we see that our program is running and that it doesn't exit. It's lying here waiting for messages. And we can see that as well here that we haven't disconnected. And now I thought that I would show you what that looks like. So here, okay, this is my default host is localhost 1562. It's probably going to be yours too if you follow the instructions of LavinMQ and you don't have any special configurations. So at localhost, you're supposed to be able to find this. And here you have a lot of tabs. This is the LavinMQ interface, by the way. Here you have a lot of tabs, and in the queues tab, you can see that we have declared a queue that's called my queue. And you can see that on this queue, we have one active consumer here. You can see the IP or the address here, and you get a consumer tag so that you can identify what consumer it is that's connected. And here we have a empty graph for now because we haven't really gotten any messages published to the queue. But here we're gonna be able to see whenever a message comes in to the queue or is consumed from the queue. Like any activity is going to be able to be visually displayed here. So yeah, but we'll come back to this view. But now we have our consuming app. Now I think it's time for us to start coding our publisher. So I'm going to create another file, and I'm just going to call this publisher.crystal. This app is going to be very similar to the consumer. We're going to do the same thing that we're gonna require the AMQP client, and we're going to start a connection towards LavinMQ. And on that connection, we're going to open a channel. So that's going to look basically the same. AMQP client. I'm going to let GitHub Copilot help us here. And we'll do, I'll just do this and I'll delete what comes up here. Okay, so now we have like the skeleton. That's pretty similar to what we have here. But the logic of the publisher is obviously going to be different. So here we're just going to find our queue. So we're going to do channel.queue equals to my queue. Right? So there we have the queue, and then we're going to create our message that we want to send to our queue and that our consumer is going to consume. So I'm just going to say message equals to hello world. Very simple, from publisher, just so that we can kind of distinguish them. Yeah, and then I am going to do queue. So I'm going to use this queue that I've saved here in this variable. I'm going to do queue dot publish confirm like this, and I'm going to publish the message like this. And after I have published the message, I am going to say that it's supposed to output sent and then the message, just so that we can see some type of feedback from our program. Yeah, and like I said earlier, you're not publishing directly to a queue, even though it looks like that right now. The AMQP client is smart in that way that when you don't give any input parameters to this method, more than the message, it's going to go to something that's called the default exchange, which is going to put the queue name that we've defined up here as the routing key. So it's going to just like route directly to the queue that you have specified, basically. So we are publishing to an exchange, even though it looks like we're publishing to a queue. Okay, so this is going to be our very simple publisher. So we're just going to create a message and we're going to publish that message to our queue that's called my queue. So let's see if that works. Let's just do crystal run publisher.crystal. And hopefully that compiles. Yeah, okay, cool. And what you can see here then is that, okay, now this, you could probably do message dot. Okay, no, I'll skip that for now. Okay, but you can see here that we have sent this message, hello world from publisher, and that we have received that message on the consumer, and that you should be able to see some activity here in the chart of the queue on the LavinMQ interface. So you can see here that we get a spike, and that means that we've published and consumed a message on this queue. And as you can see, we have a total of 0 messages, which means that our consumer has just like instantly consumed the message. But if I were to disconnect our consumer and then publish a couple of more messages to the queue, you're going to be able to see here that that count is going to go up, and it's going to stay here at a total of 2 messages now, because there's no consumer actively consuming from this queue. But as soon as I connect my consumer, it's going to consume those messages again, which you can see here, it goes down to 0, and yeah, you can see the messages being consumed here. Yeah, I'm just going to check my notes to see if I have missed anything. And no, I think that that's like basically what I had to show you guys for the examples. Now let's see here if we can get back to the slideshow. Okay, this is harder than I thought. Okay, yeah, here we go. Yeah, I have some QR codes here that I just thought that I'd leave up during the time that we maybe have to answer some questions, if there are any questions. And yeah, one of them goes to the GitHub, and one of them goes to the LavinMQ Slack that we have, that you could join, and like we can talk about your use cases or the challenges, or yeah, whatever you want. But yeah, that was all that I had for like the live coding session. If you guys have questions, me and Yor would love to answer them. Okay, Yor, I think that you are muted still.
Okay. All right. So I think there's one question here, something about, is it like Azure Event Hubs?
Yeah, right. I mean, yeah. Do you have an answer, or? Okay,
I could comment on. Okay, no, you go. Yeah.
Okay.
Yeah.
There's like a little delay between.
Yeah.
Okay, well, my comment, I guess, is that you could say that they are similar because they're both like messaging middleware, like you use them both for messaging, but yeah, like their purposes are probably a lot different. I mean, I'm not an expert on Azure Event Hubs. I haven't used them personally, but they're probably optimized for a different use case rather than RabbitMQ or LavinMQ. That would be like more throughput performance based, I guess.
Yeah. Yeah, sounds about right. Just to add to what Christina had said, yes, like Azure Event Hubs is mostly for event streaming, but LavinMQ is primarily for message brokering. So if you're looking for something that is close to LavinMQ in the Azure ecosystem, then you probably should be looking at the Azure Service Bus, because it's a managed message broker by Azure, by Microsoft as well. Yeah. Do we have other questions? What are the best use cases for LavinMQ for hackathons, student developers? Good question. So apart from the microservice or using it between microservices, which is what our challenges are about. One of the common use case is you could use it as a scheduler to schedule emails. Like if you want to send out emails, you could use LavinMQ for something like that as well. Christina, do you want to add to that or?
Yeah, no, I think that's a good use case. I mean, the use cases are endless, really. You could, like anything that's event based, you could use LavinMQ for. So anything that you have one service that needs to tell another service to do something, like sending an email or yeah, basically anything. You can use LavinMQ for that. Yeah. And I guess if there's any other questions that come up during the week that you want us to answer or that you need help with the challenges, we're going to be answering any questions that you have in Slack or in Discord. So
Yeah.
we're going to be here for you. Yeah. So yeah, don't be scared to connect. We would love to discuss and stuff like that.
Amazing. I'm sorry. Go ahead, Nior.
No, I was just saying rice. So.
It looks like we have another question from Luna X145. Can you explain a little bit about the difference between the message queues and event streaming?
Right. So, I mean, message queues that we've been talking about are like, I guess you publish and you consume and you do that once, while event streaming or like message streaming could be more of like a repetitive process. For example, message streaming in Kafka, where you can reread messages multiple times. And that's not something that you do like with the default usage of like a message broker. However, some message brokers like LavinMQ and like RabbitMQ do have like things that are called stream queues, where you have more like streaming capabilities so that you can reread messages like that, but it's not like the sole purpose of the message broker or like the default. Yeah. Do you have a comment for that, Newer, or?
Yeah, I do have one. So when you think about message streaming, most times are you dealing with things like activity data. So for example, if you want to track clicks, so you're dealing with huge amounts of data per second. So most streaming platforms are designed to handle this high throughput scenarios, but message queues, most times they're not designed to handle very high throughput scenarios. So I guess one key difference you could mention is with message streaming platforms, you're dealing with very high throughput, but then with message brokers, you're not really dealing with so high throughput scenarios.
Amazing. Thank you both so much for joining us. We really appreciate you answering the questions. Once again, check out the LavinMQ Slack at the link there. And it looks like Luna says, okay, thanks. So great, great answer to the question there. If you want to reach out to the folks at LavinMQ, once again, reach them at Slack. You could also go to the MLH Discord channel and check out the Ask LavinMQ channel, and we'll be sure that the questions get answered there as well. Outside of that, really, thank you so much, Christina and Yor. Really appreciate having you here today. Appreciate you spending the time. Outside of that, thank you all for joining, folks at Global Hack Week Open Source. We hope you continue to enjoy the rest of your day. Keep it locked because we do have another workshop coming up after this. But outside of that, yeah, make sure you check out the challenges for LavinMQ, set up a message brokering system, something like that, anything event-based, as they mentioned. Maybe like some automated workflows that you want to work with, things like that. Definitely give it a go and check out some Crystal. Outside of that, once again, have a great day, y'all. Really appreciate you coming, and see you soon. Bye.
Thank you. Bye.
Bye. Yeah.